बिस्मिल्लाहिर्रहमानिर्रहीम। रब्बिश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. Today we will cover example 2.3, average and instantaneous velocity, from the book Physics for Scientists and Engineers with Modern Physics by Serway and Jewett, 10th edition. A particle moves along the x-axis. Its position varies with time according to the expression x is equal to minus 4t plus 2t square, where x is in meter and t is in seconds. The position time graph for this motion is shown in figure 2.4a. Because the position of the particle is given by a mathematical function, the motion of the particle is known at all times, unlike that of the car in figure 2.1 where data is only provided at 6 instants of time. Notice that the particle moves in the negative x direction for the first second of motion, is momentarily at rest at the moment t is equal to 1 second, and moves in the positive x direction at times t greater than 1 second. Figure 2.4a, position time graph for a particle having an x coordinate that varies in time according to the expression x is equal to minus 4t plus 2t square. Figure 2.4b, the particle moves in one dimension along the x-axis. Figure 2.4a is plotted using the expression x is equal to minus 4t plus 2t square. Figure 2.4b shows that the particle moves in the negative x direction for t is equal to 1 second. It is momentarily at rest at t is equal to 1 second, and for t greater than 1 second it moves toward the positive x-axis. Part A of the example, determine the displacement of the particle in the time intervals t is equal to 0 to t is equal to 1 second and t is equal to 1 second to t is equal to 3 seconds. From the graph in figure 2.4a, form a mental representation of the particle's motion. Keep in mind that the particle does not move in a curved path in space such as that shown by the red-brown curve in the graphical representation. The particle moves only along the x-axis in one dimension as shown in figure 2.4b. At t is equal to 0, is it moving to the right or to the left? During the time interval, the slope is negative and hence the average velocity is negative. Therefore, we know that the displacement between A and B must be negative number having units of meter. Similarly, we expect displacement between B and D to be positive. In the first time interval, set Ti is equal to Ta is equal to 0 and Tf is equal to Tb is equal to 1 second. Substitute these values into x is equal to minus 4t plus 2t square and use equation 2.1 to find the displacement. Delta x a to b is equal to xf minus xi is equal to xb minus xa. To find xb, we will substitute t is equal to 1 in equation x is equal to minus 4t square plus 2t square. To find xa, we will substitute the value of t is equal to 0 in the expression x is equal to minus 4t plus 2t square. Once we subtract xb minus xa, we get the answer of minus 2 meters. For the second time interval, t is equal to 1 second to t is equal to 3 seconds, set ti is equal to tb is equal to 1 second and Tf is equal to Td is equal to 3 seconds. Delta x b to d is equal to xf minus xi. Xf is the final displacement, xi is the initial displacement. This is equal to xd minus xb. To find xd, we will substitute t is equal to 3 seconds in the expression x is equal to minus 4t plus 2t square. To find xp, we will substitute the value of t is equal to 1 in the expression x is equal to minus 4t plus 2t square, and then we will subtract xt minus xp, giving us the answer of 8 meters. Now let's do part B of the example. Calculate the average velocity during these two time intervals. In the first time interval, use equation 2.2 where delta t is equal to tf minus ti. Tf is the final time is equal to tb and ti is initial time equal to ta. If we subtract tb minus ta, we obtained 1 second, which is equal to delta t. Vx average a to b is equal to delta x a to b divided by delta t. We know from part A delta x a to b is equal to minus 2 meters, which means that particle is displaced by 2 meters to the left. Therefore, delta x a to b is equal to minus 2 meter and delta t is equal to 1 second, giving us Vx average from point A to B to be minus 2 meters per second. In the second time interval, delta t is equal to 2 seconds. Vx average from B to D is equal to delta x B to D divided by delta T. We know from part A that delta x B to D is equal to plus 8 meters, which means that the particle is displaced towards the right by 8 meters, divided by delta T, which is equal to 2 seconds, giving us Vx average from B to D to be plus 4 meter per second. These values are the same as the slope of the blue line joining these points in figure 2.4a. Now let's do part C of the example. C, find the instantaneous velocity of the particle at t is equal to 2.5 seconds. Calculate the slope of the green line at t is equal to 2.5 seconds. Point C in figure 2.4a by reading position and time values for the ends of the green line from the graph. Find the instantaneous velocity at t is equal to 2.5 seconds. A tangent is drawn. It is represented by the green line. If we see the value at t is equal to 3.8 seconds, the displacement is equal to 10 meters, and at t is equal to 1.5 second, displacement is equal to minus 4 meter, giving us the change in displacement to be equal to 14 meter divided by time interval, which is 3.8 minus 1.5 second is equal to 2.3 second. Therefore, 14 divided by 2.3 second gives us the instantaneous velocity of plus 6 meter per second. Notice that the instantaneous velocity is on the same order of magnitude as our previous result, that is a few meters per second. Is that what you would have expected? May Allah bless us all. Thank you for watching. Allah Hafiz.